Today's lesson is on angles, and we're going to talk about three different types of angles. These angle types are reviews, so this may seem familiar to you. Acute angles are angles that measure less than 90 degrees. Right angles are angles that measure 90 degrees, and obtuse angles are angles that measure more than 90 but less than 180 degrees. So if we take a look at an acute angle, and we look at the different parts. This point here, where the two rays meet, is called a vertex. Off from that vertex, we have rays that point off in two different directions. And when we're measuring angles, we're measuring the distance from one ray to the other. And we measure them in a unit called degrees. That's what this little symbol here stands for. So acute angles are going to measure less than 90. Right angles are probably the easiest ones to spot. They measure exactly 90 degrees. It's like a straight across, straight up L. Many times you see right angles marked with this box in the corner to show that it is a right angle. An obtuse angle is more open than a 90-degree angle because it measures more than 90, but we say it's less than 180 because at 180 degrees we would have a line. This would be a 180-degree angle. We have a line that's called a straight angle. So that's another type that we're not really dealing with, but just so that you know why it has to be less than 180. If we're looking at angles and we're trying to identify them as acute, right, or obtuse without using this tool down here, the protractor, there's a little tip or a little kind of a tool you can use. Since we know right angles have to be straight across and straight up like an L, if you look at an angle such as this one, it's going straight across, straight up would be the right angle. So that means this angle is more closed. It's smaller than the right angle, so that's how we know it's acute. In this angle here, if we go straight up from the vertex, we would have, we go straight up from the vertex, this would be the right angle. Since this angle is more open, it's an obtuse angle, it's more than 90 degrees. So that's just a way to eye them. But as I mentioned, we have a tool. This tool is called a protractor. And the protractor is the tool that is going to measure the distance between one ray and the other here on the angle itself. You can think of a protractor as a ruler for angles. All of the markings around the protractor mark the number of degrees in an angle. And today in class, we started learning how to draw angles. So the first thing students were asked to do was to use the straight edge part of the protractor to just draw a straight ray, and then move the protractor out for a second. You're to draw a vertex onto their ray, and then the arrow to show which direction the ray is pointing. Once that's set, you have to know where to place the protractor in order to measure the angle. There is a hole here in the bottom base of the protractor, which might be a little difficult to see in the video, but in your protractor, you'll see there's a hole here. That hole should cover should be where the vertex goes, right inside that hole, like that. Coming out from the hole, you see these kind of crosshairs. There's one going to the right and one going to the left. Those are going to be the most useful for us. So we're going to use this protractor, pull it down with the hole is over the vertex. That crosshair that's coming out of, if we pull this up a second, we'll see that the crosshair coming to the right of the center will cover right on top of the ray that we drew. It's hard to see when we pull it over because that line kind of disappears, and that's what we want. We want the hole here over the vertex and then this crosshair to cover the ray that we just drew. Now if we want to draw a 40-degree angle, our bottom ray is pointing to the right, so we're going to start counting using this set of numbers. 10, 20, 30, 40. Stop at 40 degrees and make a little mark there. And once we do that, we can take our protractor and we can line it up so that the mark we made lines up directly with this vertex. and we can use the straight edge of our protractor to draw the other way. And then after we draw that other way, we should always get our protractor back in place. Let's tilt this back. Get this back in place and remeasure, and make sure that it does indeed measure 40 degrees. The bottom ray is pointing to the right, and we count 10, 20, 30, 40. So that's a 40-degree angle. You might wonder why there are two different sets of numbers on the protractor. Well, if we choose, first of all, let's not forget we want to mark this as a 40-degree angle, which would classify it as acute. Now, if we're going to draw another angle, and we're going to use this to draw our straight edge, this time we're going to put the vertex on the right side of the ray and the arrow on the left. Do the opposite. We'll pull the protractor down, so again the vertex is in the hole, and the ray that we drew will be here on this crosshair. This line will cover it. So our bottom ray is pointing to the left. So now when we look to the left side of the protractor, we're going to start counting using this top set of numbers instead. We'll start counting at 10, 20, 30. I want to go all the way around and draw a 120-degree angle. 120 degrees is way over here. So I will make a mark at the 120 degrees. And you can make that mark here on the top part where the 120 is, or right under here. That line is in the same place. So again, what we did is we drew the ray, put the vertex in the point, and we were able to line that protractor up over the vertex with the bottom ray covering into the crosshairs. Let me just tilt this just a bit to get it in place. All right, there we go. And I started counting on the left side with 10, 20, 30, 40, 50, 60, 70, 80, all the way around to 120, which puts it way over here. So now I can take the protractor and use it to help draw my straight edge. So I can take that protractor, use it again as a straight edge to line up this mark that I made at 120 to match it up to the vertex. I can put arrow on that end. This should be 120 degrees, which by definition makes it obtuse. And again, we want to make sure that the angle truly does measure 120 degrees. So we'll use our protractor again. Pull it down, put it over the vertex, line it up on that bottom ray, and start counting using that set of numbers, and it comes out to 120 degrees.